All right, welcome back. So let's implement insert on our max binary heap class. But first, we need to actually define the class. So I'm going to do that now. Max binary heap. It's super simple, at least the skeleton of it is. We have our constructor, and all we have is the property values, which is an empty array. That's where we're going to store the heap. And down here, I just have in the comments sort of our initial, this is exactly the same representation, or it's the representation of this data here, just so that we can work with it and visualize what's happening. So the pseudocode, we're going to define a method called insert. It takes an element or value, and the easiest part, we push it on to this dot values, just add it to the end. So for example, if this is what values look like, if we just pushed 55 onto the end, that's the first step. Then we need to do the harder part, which is bubble up. And I'm going to define a separate method just to do that, just to keep this. I just personally like to do it this way. You definitely don't have to. You can do all the logic here. So I'm going to call this dot bubble up, which doesn't exist. So I'm going to define that bubble up, and then in here we'll put the actual logic. So remember, what we need to do is take this item, take the index of this item, in order to find the parent, which is going to be, if this is index of 6, we need to take 6 minus 1, which gives us 5, divided by 2, which gives us 2.5, and then round down, or floor, which gives us index of 2, which is this. So let's make a variable to store the element and also its index. So we're just going to find the last element. So that's going to be this dot values dot length minus 1 gives us the index. So let's make a variable called index. This will keep track of where the newly inserted item is. It will start as the last index, but if we swap, we're then going to update index to be here, for example. And if we swap again, we'd update it to be wherever we swapped with. I'm using let and const, just it's good to include some ES 2015 syntax. So that's the index. I'm going to make a variable just to store the value of the element itself. So const element, so index is going to be changing, const will just stay as the element. So it's going to be this dot values idx. This is just an easy way. I mean, we could also make it so that the method bubble up accepts the element, and you wouldn't have to do this. I'm fine with how it is here. So we're grabbing the index 6 in our case. And when I say in our case, actually, right now there is no heap that exists. So I should do that now. Let's do let heap equals new max binary heap. And I'm just going to initialize it. I'm going to cheat and just have it start as this so that we don't have to insert those manually. Then we're going to call heap.insert 55. Okay. So if we've just done that, we've added 55 to the end, we've called bubble up, index is 6, the element is 55. Okay, now what we want to do is loop. So I'm going to start with just a while true and just continue to loop over and over and over, and then break out at an appropriate time. So our process is going to be to take this element and compare it to the parent element. So first we need to find the index of the parent. So to calculate that, I'll make a variable called parent idx. Remember the formula? If you don't, it's over here. We take the floor of the index minus 1 divided by 2. So I'm going to do math.floor, and then we need to add extra parens, subtract 1 first, and then divide by 2. Okay, so let parent index equal math.floor, index minus 1 divided by 2. And actually, let me just get rid of the loop for just a moment. Let's just do a console.log parent index to make sure that's working. Run my code. Oh, 3 B's. That's not correct. Hopefully you saw that before me. Try that again. Okay, so it's giving us 2, printing out 2, which is the parent index. Is that correct? Let's look. 0, 1, 2. That gives us the element 33. That is indeed the parent of 55. And if you wanted to verify that based off of this sort of a visualization, you can see 33 is the parent. Okay, so now what we want to do is compare the item at this index to our element 55. Compare those two things. So we have the index of the element and we have its parent index. So now let's do a comparison. So I'm going to make a separate variable to do this because it's a little bit shorter. So let parent equal this dot values of parent index. Because we have to, we don't have to do a variable, right? We could just compare this, but I like to just label it as parent. Then what do we want to do? Well, if parent, we could do it either direction. If element is greater than parent, that means we want to swap. So I'm just going to do this dot values of parent index equals element. So that's putting 55 here. And then we need to set this dot index, this dot values of index to now be parent. So that should swap the values at least one time. We're not looping still. So, and that's only if the element is greater. So in our case it is when we insert 55. Let's just see if it works. Okay, so let's look at our heap now. And you can see we have 55 where 33 used to be. So that's correct. Now we just need to get it to happen again, or keep happening. While what? Well, I'm going to keep it as while true for now. But I'm going to change my loop a little bit. So we're getting the parent index, we're getting the parent, we're checking if the element needs to be swapped, then we're swapping. But if we leave it at this, we're going to have an infinite loop that goes forever. And also, we're never updating index. Index is always still remaining 6. So every time through, parent index is going to be this. So we're going to be comparing 6 and 2, those indices, over and over and over. So what we want to do is actually update index to be parent index. Because if we swapped 55 and 33, we now need to look at what's at 55 and find its parent. So we need to change index to be this, the old parent index. So we're almost there. But rather than doing it this way, where I'm checking if element is greater than parent, I'm actually going to change my logic entirely. Well, I'm going to flip it on its head and change this conditional to be the opposite. If element is less than or equal to parent, if that's the case, break. And then otherwise do this. So it's just a slightly shorter way of saying that. So while true, forever, find the parent index, find the parent, the value there. If the element is less than or equal to the parent, break, we're done. If that's the case, if, for example, we inserted, 11, we compare 11 to its parent 33, we don't swap, we're done. However, in the case of 55, first time through, this is what we had. Then we swap, so that we end up with 33 here and 55 here. And then index now is this, and parent index is right here. So we're working with 0 and 2, and we compare again, and we swap again. So if we actually look at what we get, it's still not going to be totally correct. But if we look at heap, you can see that 55, okay, you can see what's happening. We got a swap where at index 2, we have 41. That's correct. So we swapped 41 and 55. So we went from, I'll just put them all in a row. From this, where we had 55 at the end, we swapped it to here. Then we went to this, where we swapped 41 and 55. But our code keeps going one more time because it's trying to compare 55, which is index of 0. And then it's trying to find the parent index, which is 0 minus 1, negative 1 divided by 2, rounded down or floored down, index of negative 1, which is going to be undefined. And it's comparing undefined to 55. And so you can see it actually does a swap, and we end up with 55 at index of negative 1. So this is a simple fix. We just want to stop, instead of while true, let's just say while index is greater than 0. Because if index is now 0, we know that the element is the largest element. For example, 55, if we swapped it again, we should stop now. There's nothing we could swap it with, so just stop. Now, let's test it out and see if it works now. Look at our heap. All right, we have 55 there. Now let's insert something that's not as large. Let's insert something that isn't going to be swapped at all. Let's do like 1. Look at our heap. Nope, not hiao. If we look at it, you can see, all right, it stays at the end. Now let's insert something like, I don't know, how about 45? And we look at the heap again. So we made a swap with 18. So it was at the end here, we swapped it. So then 45 is right here, and then we did one more swap between 45 and 39. And so we end up with 45 right here, and that's correct. And then finally, let's just make sure if I try and insert something massive that is larger, 199, it should bubble its, oh my gosh, the same typo again. It should bubble its way all the way up top. Let's just look at the values. And it does. Okay, so that is insert. Again, it's just one way of writing it. There are many possible variations, but they all follow the same idea where you insert it at the end and then you bubble it up to the correct spot.